Previously, we learned how to simplify radicals that had a product underneath it. So we simplified the square roots. And then we also learned how to multiply square roots and then afterwards simplify out the perfect square. So for this part of the lesson, you'll still need to know your perfect squares because we are going to learn the division property of square roots. So for a is greater than or equal to 0 and b is greater than 0, we have the property, if you have the square root of a divided by b, we can separate those so that we have the square root of a over the square root of b. An example of this is below. The square root of 36 over 49. We can separate this into two different square roots. And then if you look at that, you'll realize that we have perfect squares in the numerator and the denominator of this fraction. So the square root of 36 is 6, and the square root of 49 is 7. So our answer here is 6/7. And we'll leave it as a fraction. We don't need to write it as a decimal. So I'm going to do some of these examples down here. If we look at square root of 64 over 49, we can separate those into two different square roots. And then again, we can look at that and we will realize that the square root of 64 is a perfect square. That is equal to 8. And then the square root of 49 is 7. So our answer is 8/7. So let's do the same thing with 100 over 4. We have the square root of all of that, so we can separate it into the square root of 100 over the square root of 4. Square root of 100 is 10. And then the square root of 4 is 2. And that one we can simplify because it simplifies to a whole number. 10 halves is another way of saying 10 divided by 2. And 10 divided by 2 is 5. Our final answer there would be 5. So now these next two, they're a little bit different because we have square roots, or we have variables underneath the square roots. So what we are going to do with these second two examples is we're going to split up everything. We're going to separate this into the square root of 25 times the square root of x to the 4th over the square root of 36. So the numbers are simple. We can simplify those first. We can simplify the square root of 25 as 5. The square root of 36 is 6. Now the square root of x to the 4th, that's a little bit different because it is a variable. So we're going to write out x to the 4th in expanded form. And remember that x to the 4th really means x times itself 4 times. And if we relate this back to 25, remember that the square root of 25 can be rewritten as 5 times 5. We see 2 5s there, and only 1 5 gets written out front. So it's the same thing with the x's. We're going to group them because it's a square root. We're going to group them in groups of 2. So circle your groups of 2, and there are 2 groups of 2 x's. So that means that we have an x out front, and that those 2 5s became 1 5. So these 2 x's, when you're taking it out of the square root, will become 1x, and same thing with the other x. So we have 5x times x. It's going to give us x squared. And then over 6. Another way of looking at this is that you have one group of x's, and you have two groups of x's, and that's how you get your exponent. So that's how we simplify square roots with variables in the underneath the square root as well. So we're going to do the same thing with the square root of 9 times y over 4. We're going to separate it so that we have the square root of 9 times the square root of y over the square root of 4. Square root of 9 is 3. Square root of y stays for now. And then we have the square root of 2, or square root of 4, which is equal to 2. So the square root of y, we don't have any pairs underneath there. There's only one y, so we can't take it outside of the square root at all. So that will be our answer. That will be our final answer. All right, and now you can try some of those division property of square root problems on your own.